Okay, we're going to start some work on arithmetic progressions, and we've got an example here we're going to look at. And its first one is just find the 28th term of the sequence, and all I give you here is the first four numbers, so -5, -2, 1, and 4. So the solutions that you're going to get, we've noted that this is an arithmetic progression with parameters a, so that's the first term. It's another, it's like t1 if you like, equals -5, and the difference between each term is 3. Okay, so using our formula that we've got, and I'm hoping by the time you hear this we've actually introduced this in class, that for an arithmetic sequence we can work out that Tn equals a plus n minus 1 times d. So this is how to work out the nth term of a sequence, where all you know, so long as it's an arithmetic one, where all you know is the first term and the difference between each term. Okay, so you put n equals 28, and we see that the 28th term is -5 plus 28 take 1 times 3, which is going to give 76. So that's how we can do that one. If all we've given is the first four terms, or even the first three, really, even, and we know that it's an arithmetic progression, we know the first term and the difference between each term, then we can then work out any subsequent term. And that's the formula we use there. Okay, example 2, pardon me, we've got a sequence 1, 5, 9, 13. What position I've worded that funny, what position term is 385? In other words, which term is, which is it, the 20th term, the 30th term, whichever. So we've got an arithmetic progression with a equals 1 and d equals 4, because we can see the difference between each number in the sequence is 4, and therefore we've got this, that the nth term is given by a plus n take 1 over d. Now they're telling us now that Tn equals 385, and we're going to try and find out what n is, which number term is this. So it's just a matter of substituting and solving that equation, which is really quite easy. That's just a year 9 linear equation. 385 equals 1 plus n take 1 times 4. So they've actually, if you have a look, they've expanded this bracket and just moved everything over here. You've got 4n take 3, which is they got from expanding this and adding that, equals 385. Add 3 to both sides, and now divide by 4, n equals 97. So the 97th term of this sequence is 385. Yep, 385 is thus the 97th term. Okay, let's look at example 3. In the sequence, in this given sequence, what is the 9th term? So this is a geometric progression with a equals 2 and r equals 3. Now, there's a equals the first term, and if you see r is just the ratio of any term to the term before it. So if you look r at -3, 6 divided by 2 is -3. 18 divided by -6 is -3. 54 divided by 18 is -3. That's how we work out r. R is basically Tn plus 1 divided by Tn. And we know that geometric progressions look like this. Tn equals a times r to the n take 1. Now with n equals 9, a equals 2, r equals -3, we're going to have Tn equals 2 times -3 to the 8th, and that comes to 13,122. Okay, so this is a geometric progression. It follows this formula here, and this is how we can actually work out. So got example 4 now. This is a bit like the other one. Sorry, now we've got the, sorry, I'm not going to do a geometric one. We're going to do this is now a series. We're going to find the sum of 1 plus 3 plus 5 all the way up to 73. Okay, the solution. This is actually an arithmetic progression with a equals 1 and d equals 2. You can see the difference between each term is 1. So these are the terms in the sequence as 1, 3 and 5. And it's the sum of these terms. So in other words, what we can do is we can use this again, our Tn or Sn, it doesn't really matter. This is finding the sum of an arithmetic progression is n divided by 2 times 2a plus n minus 1 over d with n equals 73. So sum 73 is 73 over 2 times 2 plus 72 times 2, and this comes to 5,329. Okay, so there's a few examples. I think we've got, another example coming up, example 5. We're going to find the sum of that series. So if you have a look, this is an arithmetic progression with a equals 1 and d equals minus 4. So you can see every time the difference is minus 4. And we're going to sum these. So it's like saying that's the first term, that's the second term in the sequence, third term, and we want to find the sum of those down to 199. Okay. First of all, we need to find what number term that is. Okay, so first we use this one here to find what number term that is, and we find out using this formula that n equals 51. So this is the 51st term. Now we need to find the sum. So S equals n over 2 times a plus L. Okay, we put L with n equals 51. Okay, why have we got an L there? That's a bit strange. So L is simply the last term there. And we get the sum comes to that, which equals, can't quite see it there, I'll just move that down for you. And that comes to 5,049. Okay, we'll go on to example 6. Find this sum. So is this an arithmetic or a geometric progression? Well, it's a geometric progression, progression with a equals 1 and r equals minus a third. So first of all, we're going to use that formula to find the sum. Do we know what n is? Well, here it looks like they're telling us that n equals 8. Okay, n equals 8. That's to the 8th term there. And we get all that, it actually comes to 0.75. Okay, so find the sum of minus 1 minus the positive to the 8th term. That's what that means there. Okay, so just go through those. This is basically about the only examples that we're going to give you. Go back there from the beginning. Slideshow. Yeah, they're the only ones we're going to actually give you. These example ones, these types of ones are the ones we're going to give you in tests and whatever. And there's the basic 6 different examples that I want you to have a look at.